Hello everyone. In this lecture, we are going to see the proof of Theorem 7.5, which is also known as RHS congruence rule. That is, this theorem states that in two right triangles, that means this theorem is only applicable in case of the triangles are right angle triangles. The hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. That means here it is given two triangles ABC and PQR such that angle B is equal to 90 degree and angle Q is equal to 90 degree. Here given that two triangles are right angled and its hypotenuse also equal, that is AC equal to PR and also BC is equal to QR. BC is equal to QR. So these are the given conditions. Then we need to prove these two triangles are congruent. Exactly it is look like SSA, side angle. But there is no criteria to prove that two triangles are congruent like SSA. But in case of right angle triangle, it is applicable. But we are not simply saying it is SSA. Instead of that, we will say that right angle hypotenuse side. Right angle hypotenuse side. That is why it is known as RHS congruence rule. So how can we prove? We are going to take the help of two theorems. One is Pythagoras theorem and SSS congruence rule to prove this theorem. Which the proof of SSS congruence rule we have discussed in the last video. So let's apply the Pythagoras theorem in both the triangle. In triangle ABC, by Pythagoras theorem, AC square is equal to AB square plus BC square. According to Pythagoras theorem, square of hypotenuse is equal to sum of the squares of other two sides. Then let's write that implies AB square is equal to AC square minus BC square. AB will be this BC taken here, so it will be equation number 1. Also in triangle PQR, PR square is equal by Pythagoras theorem. PR square is equal to PQ square plus QR square. We forgot to write the aim, that is to prove triangle ABC congruent to triangle PQR. Okay. Whenever we are going into the proof of theorem, we have to mention clearly what is the given conditions and what is our aim, and if we are doing any construction, that is also clearly mentioned before we getting into the proof of theorems. Okay, now this is the proof. Then that implies PQ square is equal to this QR taken to here, so it will be PR square minus QR square. Clear? Equation number 2. Now comparing these two equations, we can write that from equation 1 we can that what is equation 1? AB square is equal to AC square minus BC square. Then that implies AB square is equal to AC and BC is equal to PR and QR. So we can write instead of AC, PR square minus instead of BC, it is QR. Since AC is equal to PR and BC is equal to QR. But that PR square minus QR square is equal to PQ square, which implies AB square is equal to PQ square. Why? PR square minus QR square is equal to PQ square. Okay. If AB square is equal to PQ square, taking the square root on both sides, that means we will get AB is equal to PQ. So after applying Pythagoras theorem, we have got AB is equal to PQ. Then these two triangles can be proved as congruent by using SSS congruence rule. That is, now in triangle ABC and in triangle PQR, AB is equal to PQ, which is just we now proved. And BC equal to QR, which is given. Also AC is equal to PR, that is also given. Then triangle ABC congruent to triangle PQR by using SSS congruency rule. Remember, this theorem can be proved without applying Pythagoras theorem also by doing some construction, but this is the simple proof which we can give for this theorem. Okay, that's all about this theorem, and in the next video I will come with another proof. Okay, so thank you all.